So that have imposed upon us this inverse-S shape that we also call likelihood insensitivity. And in behavioral approach, we also want to have theory. So then first question to ask is, what is the formal definition of inverse-S? How do you define it mathematically? And in fact, that's not a very easy question, and this recording will be dedicated to answering it. First, I put up a graph with the inverse-S probability weighting function. Our question is, how do we define it formally? Now, I first give an answer that is often given somewhat sloppily in the literature, but I think it's not a very good answer. Often people say, well, we do it as follows. We specify some point B. We say it is concave to the left and convex to the right. Maybe sometimes they say it should be above, below, diagonal some places. But anyway, I think this is not a good definition. This is not the essential concept. The essential, what is going on, what is essential is the big jumps, the steepness at the extremes, and the shallowness, no, there are jumps in the middle of the region. That is the essence. And whether in the middle of the region the function is a little bit convex or a little bit concave, that doesn't matter. So therefore, if you want to define it properly, more work to come, we have to do something different. Now, on this slide, first I'm going to give you sort of the informal version of the formal definition. Next slide will be really the formal definition completely. In this slide, I'm going to tell you the main idea of the definition without yet doing the formalization and the symbols and so on. So, the main idea is, first we specify an insensitivity region in the middle where we want the function to be shallow. And there it is, an insensitivity region we specify. Then we define inequalities that capture that the W differences in this insensitivity region are smaller than the W differences at the extremes. But then there's one point, a little bit subtle, when we compare the W difference at an extreme with another W difference in the middle, we should take care that that middle is really middle, and it's not the other extreme. So we have to impose some boundaries. And exactly, it sounds a bit vague now maybe, but in the following page I will make it precise what is going on. So now we go to the really formal definition. First put up the shape again, and then insensitivity regions. Now I introduce symbols, notation. The left bound is called BRB, the right bound is WRB. BRB means best rank boundary, and indeed here the small probabilities, small ranks, they are the best ranks. So this is indeed about best ranks. And here we find the worst ranks, hence the names that we give to the boundaries. Okay, now we're going to capture that in the middle region, this insensitivity region, that the W differences are small. Let me put up an extreme probability with best rank, so rank 0, there it is, outcome probability P, then its contribution to the rank, to 0, that marginal contribution, that is of course just the W value at P, but I write it here, that is the decision weight of P when it has an extreme rank, and it should be quite big, steepness at the extremes. Now we're going to consider a decision weight in the middle region when the rank R is in the middle. There's rank R. Now how much W gain do we get from adding P? Then first I put up the level of W. Now I add P, and then I see how much extra W do we get from it. There you see, that difference is the decision weight of outcome probability P when it has that middle rank R. And now, what I said you many times, we want that to be smaller than what happened at the extremes, so I write the inequality. The decision weight of outcome P with best rank should exceed the decision weight when it has some middle rank. Same story at the other extreme. If P has the worst rank, and that's 1 minus P, so there I put it, and then I immediately show you this is the decision weight, the extra W gain that we get. This is the decision weight of outcome probability P if it has the worst rank, and that just as much should exceed the decision weight in the middle that we specified there. So these are the two inequalities. But now we want to impose some restriction on the domain where we input them, because let me first go to the first inequality. If P has the best rank, we compare it to where it has a middle rank, but we should ensure that this middle rank is not in fact going to the extreme here and becoming a worse rank. It should be really middle. It should not pass by WRB. That's how we impose it. So we impose this inequality only on the interval up to WRB, and we can get it done, the biggest probability involved R plus P. If we say that should be less than equal WRB, that's another way of putting it. That's what we do. Similar story with here. When we compare the worst rank with the middle rank, we should ensure that the middle rank is not getting a best rank. It should be really middle, not an extreme best rank. So we should stay to the right of BRB. We impose that inequality only on the interval from BRB to 1, and it's enough that the smallest probability involved in this probability R exceeds BRB. So this is the definition. Well, now let me write in a full sentence. I should still do it, what exactly it is. So in a sentence, I say inverse-S or likelihood insensitivity holds on an insensitivity region written there. And by the way, this insensitivity region is to be determined by the modeler at the modeling stage. Then you have to decide what is you think is a reasonable region where it will hold or where you need it. So it's part of the modeling decision what the insensitivity region is. Anyway, so we say that this likelihood insensitivity holds on the insensitivity region if the inequalities 1 and 2 written below hold. So that's the formal definition of inverse-S of likelihood insensitivity. I add some more terms. You need not memorize them, but it may be convenient to have them available. The first inequality, I refer to it sometimes as best rank overweighting. Second inequality is worst rank overweighting. Further, sometimes I call that left region the best rank region, and the right I call the worst rank region. So those are a few more terms that we will sometimes use. So now we got the full formal definition of inverse-S, and that's enough for today. So here I'm gonna end the recordings for the fourth meeting, and more things to come in the next meeting.